we made a reusable blueprint for audio. We can see it here in the demonstration project. This blueprint has a sphere collision. When the player overlaps with that sphere, it starts this timer, which picks a random min and max time. This is set in the details panel of the blueprint. It's a public variable, so it's specific to each instance that you might put in your level. That timer has a function named soundTrig, which calls this custom event over here, spawns a sound, and then another function here calling this custom event, which re-triggers the timer, choosing a new random time. When we walk out of the sphere collision, that timer is cleared, so the whole system stops. We've got a couple of debug things in here, which is to print the XYZ coordinates of the sounds to the screen, and to also visualize them by spawning this other blueprint we created. Now this is all very useful, but what if we wanted to control whereabouts the sounds was being spawned? In other words, we wanted to specify that the sounds should always be spawned behind the player or always slightly above and to the right of the player. In order to do that, we'd need to know the player location, but also their rotation. So we're going to take a slightly different approach. We've still got the player character here, and we're getting their location. We're still generating some random distances, but this time we're using these. These nodes are what's called normalized vectors. They give a result between 0 and 1, which define the rotation of the player character. The get forward vector is essentially the direction in the x-axis, the get right is the direction in the y-axis, and the get z is the direction in the z-axis. By multiplying these vectors with our random distances, and then adding the resulting vector to the player's location, we can now spawn the sounds at these distances from the player, but they stay relative to the player's rotation. So we can specify sounds as coming from in front or behind, from the left or from the right, above or below. Now we could define a bunch of public variables here for the min x, min y, min z, but we already know a variable that contains x, y, and z, and that's our vector variable. So instead here, we've created a min vector and a max vector, and we can see now we can specify min xyz and max xyz. Just to prototype this quickly, I've put in a really short time, so 0.2 of a second. It's going to spawn loads of sounds very quickly, and they're going to be at min minus 400 and max minus 400. So in the x-axis, this means the sounds will always be spawned behind the player. Got a bit of variation in the y, so minus 400, so to the left of the player, plus 400 to the right of the player, and then a little bit of height variation. So let's see how that works. I'm going to go into our area. I'm going to get the flying camera with F. We should see all these sounds being spawned behind the player, but with some variation in the y-axis and the z-axis. At the moment, the blueprint operates around the player. That's how we've designed it. But we can think of other instances where we might want to spawn sounds around a particular object in the game. So for example, in the meadow area, we've got these beehives. So could we use the blueprint here to spawn random bee sounds coming from around this position? This is quite a simple addition to our blueprint. We're getting the character's location and its vectors, so all we need to do instead is to get a reference to the blueprint itself, get its location and its vectors. So if we go get reference to self, here, what we want to be able to do is to choose between these two options. And to do that, we can use a select node. If we connect the select node up to the location, forward vector, right vector, and up vector, and we're going to create a Boolean here because we've got two options. And if we call our Boolean player origin, then when our Boolean is true, we will use the player as the origin of the sounds. And when it's false, we'll use the blueprint itself. We'll make player origin public, go back to the level. Of course, we need to compile the blueprint first before we see those changes. So let's find our blueprint and we'll get a reference to it, put it near those beehives there. We're going to make the sphere radius a bit bigger because what we don't want is for all the sounds to suddenly appear when the system switches on. We want to hear them actually working from a distance. We'll set a short time again so we can generate quite a lot of bees in that area. And we'll say it can come from behind the blueprint or in front of the blueprint, to the left of the blueprint, to the right of the blueprint, and we'll put in a little bit of height variation as well. You can see here our new option, player origin, is false by default, so that's okay, that's what we want. We want the origin to be the blueprint itself. We need to add a sound, it's going to be this one, and we'll try that out. So here you can see there's sounds being spawned around this area. It's got nothing to do with the player anymore. They're being spawned in those random XYZ distances from the blueprint actor itself. The other thing we might want to do at this point is to create another Boolean, which we're going to call debug, make that public, and pull it in here. I'm going to use this to control a branch node to say, shall we see this debug information or not? So branch, if debug is true, then let's print the XYZ coordinates to the screen and see the visualizer. If debug is false, then let's not do these things. Let's compile that, try it out. So now in my blueprint actor, debug is by definition false. So that's probably a good default to keep. And we'll play it. We can still hear the bees. But we're not seeing the XYZ printed to screen, and we're not seeing the visualizer. Now, those of you with a keen eye will have noticed that our blueprint looks a little bit different. It's got these shapes here. It's actually got some new variables in it. You might remember in the audio trigger, what we had was not just a sphere collision, but we also had a box and a capsule collision so that it was more flexible for different spaces. So for example, box for buildings or capsule for tunnels. And what I've done is add those here. And again, in the construction script, I've added some public variables so we can set the sizes of those. I've set all of them by default to not generate overlap events here. So they will only do so when this set is switching them on. Having created the 3 different collision shapes, we need to remember to come back to the event graph here and swap out these ones that are just specific to the sphere for the more generic event actor begin overlap and event actor end overlap. So any component belonging to the blueprint actor that's generating overlap events will fire these off. The other thing we need to do is just check that it is actually the player character. So get player character here. And does that equal the player character? Yes. And we'll control a branch from that. So if that's true and it's the player character overlapping, then start the timer. And we want to duplicate that for the end overlap. Is it the player character that has now left the collision? One final thing that differs for this player-oriented sound blueprint from the audio trigger is that the player may actually spawn inside of one of these collisions. So when we begin the game, the player may actually already be inside one, and we want our timer and system to fire off. Now, this only triggers when the player is going to overlap the collision. So if we spawn inside it, nothing's going to happen. What we want to do is we want to get a event begin play, and we want to get what actors are overlapping. So get overlapping actors of the blueprint. Now, we're not interested in everything. We're just interested in the first person character class. And that's going to create an array. Now, an array is basically just a data structure containing an ordered collection of items. What we're going to do is for each element of that array, so we're going to create a loop that's going to go through each bit of that array, and it's going to test it and say, again, is that the player character? So we're going to loop through, get all overlapping characters of that class, go through all of those and see, is it the player character? And again, if it is, let's branch and actually fire off our system. So this will work even if our player does happen to spawn inside the collision of one of these shapes. But how are we going to select between them? Well, there's 3, so Boolean is no good because that's only true or false. We could use an integer switch, but then we'd need to remember that this is 1, this is 2, or this is 3. So what we're going to do instead is we're going to use a special type of blueprint called an enumeration, or enum. This is basically just a numbered list. So we're going to go to Blueprints, Enumeration. We're going to call it Audio POS Shape. Double click. And we've got three choices. We've got the sphere, we've got the box, or we've got the capsule. Okay, that's all we need to do for this blueprint enumeration. What that will give us now, if we right click and start searching for it, Audio POS shape, we've got a switch that is specific to the enumeration that we've just created. If we add our construction script here and link these up, this will allow us to choose between them. If we create a public variable here, let's call it shape and make it public. We compile that back in our level in the details panel. We now see that we've got this nice drop down list so that you or another colleague can use this blueprint and select the collision shape you want, box or capsule. And here we've got those public variables so that we can change the size. The final thing we're going to do is just tidy our blueprint up a bit. You can see here, this is starting to get a bit confusing. In our blueprint, what we can do is we can add these variables to certain categories, and that will help us organize them. So let's say the sphere radius is all to do with the shapes of the collision. So we'll call that category shapes. And the other things that are going to go in there is probably the box extents and the capsule radius, capsule half height, and that enum, the choice of shape itself. Let's call these time. Let's call these distance. The other thing we can do is reorder them within these categories. So let's just take shape. Let's decide on the shape first. So we'll put that up the top of that category, and then we can set the radiuses and extents. We compile that, and now back in our viewport, in our details panel of the object, we can see it started to be organized by those categories. So we've got default, we add the sound. We say whether we want the origin to be the player or the blueprint. Is debug on or off? We choose our collision shape and we set its size here. We set the time min and max, and we set the distances. We've covered a variety of techniques. We've looked at public variables to make the blueprints reusable with individual settings per instance. We've looked at the construction script, at custom events and functions for passing things around the blueprint without getting into that tangle of wires. We've looked at booleans for options or enums for choices or option lists, and finally categories for organizing our variables and making our blueprint a bit more user-friendly. Learning these techniques will allow you to make audio blueprints that are specific to the needs of your game. This will speed things up, not only for you, but for your colleagues and for the rest of the team.